we are going to look at evaluating whether some of these different statements are true or false. I'm going to get you guys started. We're going to do the first three together. And then I want you to work with a partner or a small group, and you'll look at two more together. And then we'll just kind of slowly start making our way through. But I want to look at the first three as a large group. Gentlemen, please go ahead and pull your books out for me. Any ladies that don't have their books out as well. Page 153. We want to determine the truth of these different statements. Are we accepting or rejecting these ideas, these claims? So the first claim here is that if you double just the width of a rectangular prism, then you would double its volume. This double part right here, what does that mean? Times 2. What are they telling me then?
If you multiply the width by 2.
Yep. They're giving me the scale right here, right? Scale is what you multiply or divide by to get the new amount, the new measurements, the new volume, new area, new whatever. How many dimensions are they telling us to change? Just one. Just the width. So change one dimension. If I changed only one dimension by multiplying it by 2, would that double my volume? Rectangular prisms are boxes, right? I had this lovely box of rice bits yesterday. The volume of a rectangular prism like this would be what about it? What would the volume be here? Space inside of it. How much cereal would come in the box, right? We're talking about doubling what part? The width, like this way, right? Not changing this or this, just making it twice as fat, right? Would that double my volume, the amount of cereal that I'm getting? Yes, that is true. I'm only changing one dimension, so I would only multiply by 2 one time when I think about that volume. I'm going to take my original volume. I'm going to multiply that by 2, but to the first power, this is number of dimensions that are changing. And if I multiply by 2 just one time, that's the same thing as doubling it, right? I could even draw a little picture to try to illustrate this. Please don't make fun of my boxes. I'm only so good at this. Jose, maybe I should have you draw these. You're way better at this than me. So if I had this box here and it was, I don't know, 4 inches across the bottom and 7 inches tall and only 1 inch wide, what would the volume of the whole thing be? 28. 7 inches times 4 inches times 1 inch. That'd be 28, what? Inches cubed. So if I double just the width, now this would be 2 inches here, but everything else would stay the same. To find that new volume, what would the new volume be? How much? 56 inches cubed. And 28 times 2 would give me 56, right? So my whole volume has doubled here. What about if I doubled the width and the height? Would that double the volume? No. How much would it change by now? How much?
Quadruple.
It would quadruple it. It's going to change it by 4. Why? You're absolutely correct. Tell me why.
You're doing the height also.
So we are changing 2 dimensions, which means when I think about what I'm multiplying by, I'm doubling one side, and then I have to double again, so I'm going to multiply by 2 twice, 2 squared, right? So I'm thinking this right here, except instead of a little 1 up here, now it would be a little 2. So it would be original volume times 4. Something that's 4 times bigger, we say, is quadrupled, absolutely. What about if I change all 3 dimensions? Length, width, and height. Would that make the volume double? If I change all 3 dimensions, would that make my volume double? No. What would that do to it? More?
Yeah.
How many more?
6.
Close. Are we adding or multiplying?
Multiply.
Multiplying. So take 4, and instead of plus 2, you want to do what?
8.
8. There you go. So it'd be the original volume times 8. So 8 times bigger. I want you to work with a partner or 2 partners, and I want you to look at number 4 and number 5 together. I'm going to give you guys a couple minutes to look over this. I'm going to put 2 formulas up for you to use as reference, because both of these are talking about circles, right? So the area formula for a circle is pi r squared. The circumference formula thank you. Circumference of a circle is 2 pi r. Use those ideas as you look at number 4 and number 5. I'm going to give you guys about 5 minutes in your pairs and small groups to decide whether you think these are true or false. You can draw out some diagrams. You can calculate some things. You can look at how many dimensions are changing. There's lots of different ways to go about analyzing these, but I want you to be able to justify or defend your answer of true or false.
They said radius is 4, right? I'm 4. So I did 2 pi, and the arc is 4, so 25 times 12. Okay.
It's helpful to draw out a diagram
Let's say for
and calculate it.
the 4, the circumference.
I want you to determine whether these are true or false. You could. That's one way of possibly determining.
That's 50.
You can draw a reference circle and try to determine whether it's true or false that way.
You get it?
That's simple. R is the radius. If it goes from edge to edge on the circle, and it goes through the middle, that's the diagonal. If it goes from the center
You
to
know the
edge,
radius of the circle, then you know its area.
What is it? I know it has something to do with it.
just like 5 or 7 or 6.
Area. 5, which is 3.6 times the radius. Radius is 34. But then it's by 2. So
Well,
it's
that's on the
there.
pi.
50
Pi is a
for
constant.
area.
Pi is always the same thing.
That's
Pi is 3.1415. Radius, if you go from edge to edge on a circle, and it goes through the middle, that's the diameter.
Oh, okay.
The radius is half of that. It starts at the center and goes to the edge.
Yeah, equals 4. And then for the second one, it's going to be
Question. Circumference
so I'm distracted people. Some I'm sleeping.
No.
You know that channel where they put sleeping? Yeah. So my friend keep out like, this you?
The area of the circle is
That's 296. I mean, make sure it's right.
Double the radius of the circle.
The radius is 8, and then the second one is 226. So, no, false. The last one is you know the radius of the sphere. Then you know the surface line. This is sphere. Sphere is a circle.
spheres of the ball. When you're talking about surface area, that would be, surface area is the area of the outside. So like when I'm looking at my box, the surface area is the amount of cardboard that it would take to make this.
So what's the surface area equation?
Surface area equation, I can give it to you. You don't have to have it to answer that question though. Really.
You deal with the radius of the sphere.
Area is talking about how many dimensions?
More than one.
How many specifically?
2?
Area means we're talking about 2 dimensions. And if I change the radius of a sphere, that always gets used in the area formula by doing what to it?
Squaring it,
squaring it.
so false.
Double the surface area, double the radius. I believe it is false. Yeah,
Okay, 'cause
it's
this
gonna
one's
square
very
it, not
awesome.
double it.
Okay.
Or it's gonna, sorry, it's gonna increase it by 4, by a factor of 4. It's gonna quadruple it, just like here when we change to
Don't even let me
2
go back to
dimensions.
edit the meantime.
What do you guys think on number 4, true or false? Number 4 is true. Who can explain to me what the circumference of a circle is? What do we mean when we say circumference? Yep, distance around the outside. It's the perimeter of a circle. This one is a true statement. Because when we're talking about perimeter, how many dimensions does perimeter have? Perimeter only has one dimension. Circumference, it only has one dimension that could change. There we go. Okay. What about number 5?
I think false.
This one is false. Explain to me why.
So I basically just solved it, and I solved it for 4, and I also solved it
This
for
is
like for 8.
Okay?
I just substitute the numbers, and like if you got when you square, you'll be like 50.26, and when you do 8, you're gonna be like 200 or something, which is clearly not double.
It's clearly not doubling. Does anybody know what that relationship would be? If it's not doubling, what is that relationship? It's not getting 2 times bigger. Is it getting 3 times bigger, 4 times bigger, 5 times bigger? What's happening?
204 times.
How many dimensions does area have? 2 dimensions. Even when I'm talking about a circle, circles have length and they have width. And we talk about the area of a circle in terms of the radius. If I change the radius is the distance from the center to the edge. If I change the radius, then I'm changing the length of the circle and I'm changing the width of the circle. If I only changed one of those, it wouldn't be a circle anymore, it would be an oval, right? So when I'm talking about area here, we're changing 2 dimensions. So original area, if I can spell, times 2 squared, my number of dimensions that are changing. So this would get bigger by how much? What is 2 squared? 4. This would be quadrupling. Help me out. I want you guys to look at number 6. We're talking about the surface area of a sphere. You don't need the formula for the surface area of a sphere to answer this question. Anytime I'm talking about area, we're talking about how many dimensions? 2 dimensions. Anytime we're talking about area only has 2 dimensions to work with. Surface area would be enough to cover the outside of an object, but I can still take that and lay it out flat. I want you guys to determine whether you think this is true or false. I'm only going to give you about 2 or 3 minutes. Is number 6 true or false? True or false? What do you guys think? True or false? So when I'm thinking about a sphere, how do you know if what you're looking at is a sphere or like an egg shape? How do you distinguish between those two? Yeah, like if you could put a spot right in the dead center, it's the same distance from that center to anywhere on that ball, right? With like more of an egg shape, that's not true. If you put a spot right in the center, it would be closer to these edges than to these sides, right? So a sphere works a lot like a circle does. We have a radius of a sphere just like we have a radius of a circle. I can make a sphere by taking something that is a perfect circle and spinning it. Like a coin. You guys ever done that on the table? You take a coin and spin it. You take something that's a flat circle, you spin it, and what it looks like when it's spinning is a perfect ball. So the radius of that circle would be the same as the radius of that sphere. If I change the radius of a sphere, and I'm talking about area, how many dimensions would change then? Think about what we said over here. 2 dimensions are going to change. It's going to be changing the length and the width. Even though I know I'm talking about a 3-dimensional object here, surface area would be what goes around the outside. And I know it's kind of hard to wrap balls, but if you think about a bouncy ball or a basketball, that's how much material you would need to construct that. If I change the size of a ball, I go from like one of those little kid basketballs to a full-size basketball. If I double the radius, would that only double the amount of material that I would need to make that basketball? It's going to double it in this way, and it's going to double it this way. So I'm going to multiply by 2 here and 2 again. Would it just be twice as much material? How much more material would I need? 4 times as much material. Exactly the same as number 5. For the exact same reasons. Area has 2 dimensions. It doesn't matter that I'm talking about surface area now instead of flat area. It's the exact same principle. Turn the page for me. What do you think about number 7? Given the reasoning that we just used, if I'm talking about volume, how many dimensions are we talking about?
3.
3 dimensions. This would be like the amount of air that would fit into a basketball. Not the amount of material I need to make it, that would be the surface area. The amount of air that fits inside would be the volume. If I double the radius of a sphere, how many dimensions am I changing when I'm talking about volume? I'm changing one number. Would it change the length of the ball? Would it change the width of the ball? Would it change the height of the ball? If my radius gets bigger, if the center to the edge gets bigger, would it change? You said it changes the length, it changes the width. Would it change the height? It would change the height. Otherwise, I'd end up with like an oval shape. If it's going to stay ball-shaped, it's going to get bigger this way, and this way. Changing that radius changes all 3 aspects here.
So you're talking about if you inflate it more.
Yes, if you inflate it more. Absolutely true. So if I put twice as much, if I make that radius twice as big, would it only take twice as much air to fill it up? No. So is this true or false? False. How much more air would it take to fill it up? Since I changed 3 dimensions. Close. 8. My original volume. We're going to multiply that. The radius is getting twice as big, but you said that changes it in 3 different dimensions, length, width, and height. So that would be my original volume times 8. So it would take 8 times as much air. Have you guys ever wondered at the store, when you look at different things, you're like, that's twice as big. Why is it so much more expensive than this other thing? Or sometimes it goes the other way around. This one's half as big. Why isn't it half the price? This is why. Those bigger things, if we're talking about what fills it up on the inside, it might only be twice the radius on something if it's a sphere-shaped thing you're getting, but it takes 4 times as much raw materials to make it. It takes 8 times as much stuff to fill it up. So to just double the price wouldn't make sense. They'd end up losing money. Number 8. If you double just the radius of a cylinder, then you double its curved surface area. So I'm going to draw, don't laugh at my cylinder, I'm going to draw a picture. So I have kind of like this can shape here, right? When they talk about the curved surface area, they're talking about like where the label would go on a can. Not the top, not the bottom, where the label would go. So curved surface area is this part. Can you cut the label off of a can? Can you lay it down flat? What does it look like if you cut the label off of a can and lay it down flat? Looks like a rectangle. There's my curved surface area, or a representation of my curved surface area. If I cut it off and laid it down flat. On the cylinder, what do we call this? From top to bottom. The height. Where is that represented on my picture of the curved surface area? Like the label?
The left side.
Yeah.
I didn't get that. Could
Thank
you try
you.
again?
No, Siri. So there's my height, like the left side or the right side.
Okay.
The top of that rectangle. If I were to put the label back on this can, how's it going to go? Like, does it just stay like this against the can? What's it do? Wraps around it, right? So the top of that rectangle, the top of that label is the same as what? What did you say? I still can't hear you, I'm sorry.
The height of the can.
Not the height of the can. I think I have one over here, actually. Oh, I do. Look at that. You guys to watch this very carefully. Here's my label. Pay attention to the top of the label.
Mm-hmm.
Here's the height of my can. What does the top of that label do? It's the same thing as the circumference right here. Because it goes all the way around that circle, around the outside of that circle, right? So this side right here is the same thing as the circumference. So this right here. If I double the radius of that circle, think about this can here. If I doubled the radius of this circle, what would happen to the can?
It'll get,
Is it going to get taller?
no, wider.
It's going to get fatter, right? It's going to stay the same height. It'll just get fatter around. You guys actually see this all the time, where the radius of this circle changes. What happens as you use up toilet paper roll? Circumference gets smaller. Height doesn't change. Circumference does. Distance around the outside. If I change the circumference, if I change the radius of a cylinder by doubling it, what happens to my curved surface area? Would it double too?
Yeah.
Yes, this is true. This is true. I'm changing only one dimension about this. When I look at that rectangle, the height doesn't change, but I am changing the width. I'm changing the circumference here. This one is true. Let's see. If I doubled just the height, would I double the volume? On a cylinder, on a can. If I took this and I doubled the height, would I double the amount that fits inside?
Yes.
Yes, that is true. What about if I doubled the height and the radius? What would doubling the radius do to it? It's going to make it fatter. Doubling the height would make it taller. So if I make it taller and fatter, is it going to just double it?
False.
False. Two more. If you double just the base radius of a cone, then you double its volume. I'm going to draw a cone here. That is a really bad cone. We're going to pretend it's not so bad. How many dimensions does volume have? 3 dimensions. And if I change the radius down here, how many of those dimensions am I affecting?
3.
What are the 3 dimensions that we work with in space? Height, length, and width. If I change the radius of the bottom of this cone, will it change the height? Will it change the length? Will it change the width? So how many dimensions am I messing with if I make that radius twice as big? 2. If I change the base radius, I'm changing 2 dimensions. If I double 2 dimensions, will it just double the volume? No, it's going to increase it by how much? Times 2 this way, times 2 this way. It's going to change it by 4. So this one is a false one. Last one. If you double both the height and the base radius, we would double the volume. How many dimensions would we be changing? I'd be changing all 3. If I change all 3 dimensions by doubling each of them, will it take the original volume and just double it? How much would it get bigger by? 8. So this is a false. If I wanted, this isn't a question on here, this is just my question. If I had a cone and I wanted to change one thing about that cone so that it fit twice as much inside, we already said the radius wasn't going to double it. If I do the radius and the height, it's not going to double it. What one thing could I change about that cone if I wanted to hold twice as much? If I just changed the height, if I made it twice as tall, it would hold twice as much. But the radius is different than that. Nice work today, guys. Very nice work. I loved listening to some of the reasoning as we went through this. Was it helpful to have the visuals?
Yes.
Absolutely. Some of this stuff gets really abstract, but this, we've all seen, right?